Assalamu alaikum students. I am Sir Ahmed Shah. Today we are discussing about the syllabus part of 5070 or IGCSE chemistry or GC chemistry 0620. In the previous lecture about the electrochemistry, we have discussed so many topics in the part 1 introduction, definitions, types of electrolyte, process of electrolysis, and the preparation discharge. In the second case, we have discussed the molten compound, ionic compound like lead bromide, sodium chloride, calcium iodide, and so many other molten compounds. And in the part 3, we have discussed when electric current is passed through the concentrated aqueous solutions of ionic compound like NaCl, similarly sulfuric acid or HCl acids, or dilute aqueous sulfuric acid, nitric acid, HCl, HBr, or NaCl, etc. In the part 4, we have discussed about the aqueous copper sulfate solution. When electric current is passed in the aqueous copper sulfate solution, what happened if we use carbon, graphite, or platinum means inert electrodes. And in the same case, we have discussed electrorefining or electrolysis of aqueous copper sulfate solution by using active electrode. Copper sulfate solution, the same cathode anode made by copper. Now, in this part, this lecture, we are discussing about the what is electroplating. This is one of the application of electrolysis, and the last one is the electrochemical cell. Now we are discussing in the part 5 of electrochemistry, what is electroplating, how does it produce, and how does it change. Electroplating basically a process of electrolysis through which a metal atom or ions deposited at cathode by using electric current. We know that some metals are easily corroded or rusted. So we need to prevent the metal for rusting. Some least metals like copper, silver, gold, they can be deposited onto that metal which can easily be corroded. Similarly, appearance of the copper on the spoon should be the golden yellow color, look like gold. Similarly, if nickel is deposited on the steel spoon, it should be the silvery white color, look like the rim of motorcycle and scooter rim. They are nickel plated or chromium plated. Similarly, motorcycle handles and scooter handle are chromium plated. So the appearance of the silvery white, so these metals cannot be corroded as easily, so they can be deposited onto those metals which are reactive and easily be corroded. Now we are discussing about the electroplating and what are the conditions for electroplating. Today's our object is an steel, iron steel or steel spoon can be deposited or electroplated by the copper. Now we have to start a lecture now. In the first case, when electric current is passed through the solution, what are the conditions should be for? Now we, we are discussing about the electroplating of iron spoon or steel spoon by copper. So what should be the condition? More reactive metals are coated by less or least reactive metals like copper, silver, gold, or platinum. The object to be coated is made as cathode like steel, spoon as example. Anode is of the least reactive metal like copper. Electrolyte is a compound of the least reactive metal like copper. Metal is used as anode, so copper sulfate solution should be used as an electrolyte. What happened next? Anode is dissolved and form metal ions, and these ions move into the solution, so color and the concentration of solution does not change. In the next step what is going on? in the solution. Metals ion from the solution deposited at cathode like a steel spoon with the help of the current. Now we have to watch this animated diagram. When we on the circuit, electric current flows from anode to cathode, positive to negative plate. Cathode is made by iron steel or steel spoon, and anode is made by least reactive metal like copper or silver, gold or platinum. What happened when circuit is on? The metal rod connected to the anode dissolve in the solution. It produces copper ions in the solution, and these copper ions travel towards the cathode, which is steel spoon, and deposited onto this spoon with the help of the current. Gradually, size of the anode, copper anode dissolved in the solution produces copper ions. That is why color of the solution does not change. If this iron spoon or steel spoon is to be electroplated by nickel, so we have to produce a metal rod of anode by nickel, or nickel should be used as anode, and the nickel sulfate solution used as an electrolyte. Now, nickel metal anode dissolved in the solution produces nickel ions, and these nickel ions from the solution travel toward the cathode because they are positive and cathode is negative. So this is the logic of the electroplating. If those metals which can corrode easily, they need to be prevented by the corrosion. So some metals can be deposited with the help of the electric current, but the logic behind remains same. Solution and anode both are same. If copper is used as anode, then copper sulfate solution is used because this positive plate anode should be dissolved or can be dissolved or definitely dissolved in the solution, produces their ion. If our object is electroplated with steel spoon by chromium plating, so we need chromium metal plate as anode and chromium sulfate solution or chromium nitrate solution as an electrolyte. In the case, chromium metal anode dissolved in the solution produces copper ions, and chromium ions and these chromium ions, they must travel towards the cathode, which is steel spoon. Similarly, zinc metal can be deposited on the other metal, look like nut bolts on the motorcycle and car accessories can be used. They are very silvery appearance when they are new. So galvanizing is the process of deposition of zinc metal onto the other metal. This is also known as zinc plating as well as galvanizing. Condition remains same. A soluble zinc compound is used as an electrolyte. Zinc metal rod is used as an anode, and the object which is to be electroplated should be connected with the negative plate of the battery, means cathode. So now you see it again. What happened? When electric current is passed, circuit is on, this steel spoon is electroplated by copper ions. So appearance before the reaction is look like steel, silver. But when copper ions are deposited onto this metal object, iron, steel, or steel spoon, so they can be electroplated by the copper ions. The appearance of the spoon is much precious than the previous one, and the object are more malleable than the other one, or can easily be prevented by rusting. So this technique is known as electroplating. So need to recap, if metal zinc is deposited onto the other metal, this process is called galvanizing. If silver deposited onto other metal is called silver plating. Copper is deposited onto the other metal is called copper plating. Now, in the next part of this lecture, we are discussing about the electrochemistry topic, which is called electrochemical cell or electro cell, simply chemical cell, a device which converts chemical energy, chemical reaction into electrical energy is known as electrical energy is known as electrochemical cell. Listen again. A device, an instrument which converts chemical energy through chemical reaction into electrical energy or current. This is called cell or battery. We need to construct a cell to different matters of different reactivity dipped in the strong electrolyte like H2SO4. Sulfuric acid should be used as an electrolyte. Look like our car batteries, which are water-based, not dry batteries. They contain sulfuric acid as an electrolyte. More reactive metal dissolve in the acid because metal means donor of electron. Now, in the construction of the cell, we are using two different metals and both are different of their reactivities. Keep this thing in your mind. Potassium, sodium, calcium. Metals of group number 1, lithium, sodium, potassium, rubidium, cesium, and group 2 metals, calcium to below calcium like calcium, strontium, and barium. They cannot be used as rods, as electrode because these metals are readily soluble in water. So, in the group number 2, magnesium, beryllium, they are insoluble, and rest of the other metals except group 1 and group 2 from calcium to below calcium, they are soluble in water. So, they cannot be used as electrode or as metallic plate in the cell. So, magnesium, aluminum, zinc, iron, lead, nickel, chromium, other metals, then 1A group and 2A group can be used. So magnesium is dipped in the sulfuric acid and copper also dipped in the sulfuric acid. We can use silver, we can use platinum, we can use iron. So we have to need two different types of metals. One should be the above the reactivity and second should be the least reactive. So when these metals dip in the electrolyte sulfuric acid, more reactive metals, it is neutral in nature, so it just react with sulfuric acid, produces electric current. Now you can see that more reactive metals dissolve in the acid and release electrons like magnesium dissolve. This metal act as cathode in the cell. These electrons accepted by the least reactive metal like copper. So copper metal rod used as anode in the cell. The direction of the current flow just change in the cell and different in the circuit, electrical circuit. We know that loss of electron when electric current is passed through the electrolyte by using battery or cell. So the anode should be the donor of electron. Their electron can be lost and cathode is the acceptor of electron because electrons are accepted by positive charge ion because cathode is negatively charged. So positive ions travel towards the cathode. But in the cell or the battery, the reverse direction is occur. That metal which dissolve in the acid, it produce electron. So it should be the production of current. So it is the donor of electron. So we can say that which metal can donate its electron is known as cathode in the cell. I told you several times, cell direction of electrical current direction in the cell is different than the electrical circuit in the electrochemical process like electrolysis. So these electrons accepted by the least reactive or less reactive metals like copper, silver. Greater the difference of reactivity of the metals, higher the voltage of the cell. What does it mean? It means they are the metals in the reactivity series like cesium, the highest reactive metals in the reactivity series, cesium, then potassium, cesium, rubidium, then potassium, then sodium, now lithium, then barium in the reactivity series from the group 2, the order of the element in the group just reverted in the series. Strontium, now calcium. These metals of group 1 and group 2, they are readily soluble in water, so they cannot be used as metal electrode in the cell which contain water. But magnesium and below magnesium in the reactivity series, aluminium in the reactivity series, zinc in the reactivity series, so this is the whole electrochemical series. But normally we know that if this series is confined and something can be released or removed from the list like cesium, rubidium. Now we are discussing potassium, then sodium, calcium. These metals cannot be used in the cell as electrode, but magnesium, then aluminium, zinc, iron, lead, and the hydrogen. This is called greater the difference of reactivity of the metals. In the example, we just use magnesium and copper. So magnesium and copper, they are major in difference. So this cell must produce the some potential difference which is 1.1 volt. But if we use magnesium along with the silver, the potential difference or electrical current can be produced by the cell. It should be the 1.5 volt. If I used metal of any present in the series, but not calcium, not sodium, not potassium, because these metals are readily soluble. If I use gold, then platinum, so this is called the difference between the reactivity. If one metal is aluminum and second metal is iron, so cell potential difference is very low. If metal, zinc, and iron both are used as electrode in the sulfuric acid to produce the electrical current, so the voltage of this cell is very low. So if the difference between the metals, they are very close to each other, they cannot produce more voltage, but we have a difference between the metals upper one and the lower one. So these metals can produce more potential difference or electrical current to the cell. This is called the point. This is the clarification of the point. Greater the difference of reactivity of metals, higher the voltage of the cell. Now we need to on the circuit means when magnesium and copper both dip in the solution and they are connected by the wire and along with the bulb or any other device which detect the current, then when electrical circuit is on, magnesium metal dissolved in the solution produces electron. As a result, these electrons travel by the wire, passes through the wire, and the circuit contains bulb, it lights. So electron flow from higher reactive metals to lower reactive metal. So electron releases by the magnesium or metal which is more reactive, and these electron just passes through the wire and received by the least reactive metal, and these electrons can be shared, can be dropped in the solution where sulfuric acid contain hydrogen ions, and these hydrogen ions accept electron, so hydrogen gas can be evolved. Now, you have seen so many times if the car batteries, water-based car batteries contain the cap, and these caps contain a small hole. These small holes are used to evacuate or evolve the bubbles of hydrogen gas which are produced during the reaction. So when we circuit off, we start again. So current flow from magnesium to copper in the cell means from cathode to anode. But 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 this cell is connected to the circuit. So electrochemical cell can produce electric current by the highly reactive to lower reactive. This is called direction of current in the cell, cathode to anode. But this cell is connected to the external circuit during electrolysis. Then the cathode accepts the electron during electrolysis and anode can release the electron during electrolysis. So we can say that this is the difference of electrochemical cell and electrolysis. Electrolysis current direction is different. It was from positive to negative, but in the production of the current in the cell, current produced from the highly reactive metal which is dipped in the sulfuric acid as electrolyte. So it is called cathode. The flow of current in the cell, it is from cathode to anode. That is why the upper part of the cell is considered as positive because it produces the current, and the bottom of the cell, which is zinc container, it acts as the negative part of the cell. So positive, negative. When we connect the battery or in the cell, they just produce the electron from the circuit, from the cell to the circuit, then electrolysis is to be done. Now, we have to consider more for the better understanding of the electrochemical cell. We have an example for your easiness of to learning the concept of electrochemical cell. We have an electrode, copper, which is dipped in the copper sulfate solution, and the zinc metal rod, which is dipped in the zinc sulfate solution. What happened? When both the electrodes are connected, then there is no electrical current passes through the circuit, voltage is 0.0. But after passage of some time, when the circuit is connected to each other in this way, this is salt bridge which is connected to the both the solution, making a wire, look like a wire. Now you can see that when both the solutions are connected, the cell produce electric current, which is zinc to copper, because zinc is much more reactive than copper. So most reactive metal dissolve in the solution, produce ions, and these ions are present in the solution, but the loss of electron by the zinc metal ion or highly reactive metal passes through the wire and passes through the circuit, and now the voltage of the cell can be measured. This is the easiest way to understanding the concept. How does chemical cell form? We also know that if the piece of lemon is cut in two pieces and we adjust two pins along with the connected the wire, after passage of some time, the lemon produce a current because when we add two different nails or two any common pins inserted in the citric acid or lemon, it also produces current. Even though voltage of the cell is very low, only 0.5 volt, so the easiest and simple cell also produced by using the lemon. Okay, student, today we have to complete our lecture about the electrochemistry. This is the last part of the electrochemistry topic. Now, the first part contains which topics: introduction, part 2, part 3, part 4, and the last part 5. In this lecture, we have discussed how does a chemical cell form, how does it produce electric current. Similarly, also discussing the topic electroplating. Thank you very much for your time. Allah Hafiz.